All right, what we have today is we are winding a 125 horse, 720 RPM, 10 pole motor. We've already gone through and we've stripped it all out, taken all the data, cleaned it all up, and now we're getting ready to wind it. Okay, after this thing has all been cleaned up and it's all ready to start the rewind process, the first thing we do is we go through and we insulate all the slots. Now we're going to use this Mylar insulation to slip it in there because it has these breathers that the insulation gets stuck on them while slipping them in. The insulation we use in here is the Nomex and Nomex insulation with a thin layer Mylar in between them. This has an insulation class of 200 degrees Celsius. So it allows it to get very hot because these motors tend to get pretty warm. So what we're going to do is get in there and pull these through. And we just do that until we have all 108 slots fully insulated. Okay, while we are insulating the slots, we're also going to be winding the coils for this. So what we're going to do is we're going to fit a test coil. And this is just basically a coil that we think is the right size, but we want to make sure before we wind 108 of them to go inside this motor. Down here. Alright, now this motor has a pitch or a span of 1 to 10. That means that the total number of slots, the slots that it occupies and the slots in between, is going to count to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is what we're going to have coils to drop down into. Right around here, right there, and we'll get a tape measure, and then we will compare it to the heads that originally came out of this motor and make sure that we're somewhere close. So right now we're at about 5 inches. Back of the slot. It looks like we're there about 5 inches as well, which is about where our original one is, so we know that's what we want to go with. Okay, for the next part of the process, we're going to be winding the coils. This is all the wire that we're using here. Now this wire here, this is a special kind of wire. It's called magnet wire. Basically it's just copper wire that has a thin layer of insulation on it because none of the wires can actually touch each other anywhere in the motor. This is also a high spike resistant wire that is good for running off of inverters because you can't just use standard wire. What that means, you can run that off of a something like a frequency drive. Which is getting more common these days. So we have a specific number of wires coming in here that meet a specific number of circular mills in order to handle the current that's going to be running through this motor. And over here, this is the machine that we're going to be winding all of our coils on. Okay. First thing we're going to do, pry this off. Machine. What we're going to do is we're going to spin an extra turn on here so that we have enough link on the end to make our connections. Set our counter. Okay, for the next part of this process, we're going to start stuffing this motor. Now, I mentioned earlier, some of these coils have 4 coils, or some of these groups have 4 coils, some of these have 3. These have to be put in a specific order so that it will be balanced in the end. Referred to as throw coils. So just lay down top of this piece of insulation. That's the tops of those will go down until the very end. Okay, now that we're laying down these coils all the way, in between each of these groups has to go wire a phase block. Now we put in the first coil so that we have one to hold it down. Side here, put in a piece of phase insulation that keeps the phases all separated. You can see we've got most of the coils in here now, and we've gotten to the point where we need to pull these throw coils out of the way so we can put the rest of the coils in. So what we do, very carefully, one at a time. Out of the way. The rest of the coils in, and you can lay those down. Alright, we now have the rest of the coils in here, and all that's left is put our throw coils down, these last 9. So, what we're going to do, roll these down one at a time. This out. Plus on the other end, going to remove it from this side as well. Alright, so for the next part, what we're going to do is we're going to use these coil crimpers. Crimp these all together. And then nice. Get them all wires nice and tight together. Make sure each one of these phase claws all the way down in the slot, all the way down to the bottom. got all that done, then we start trimming them. While still being very careful. Alright, once we cut the front, then we can move to the back. Basically, start doing the same thing. The next part of this process, we're going to be putting in a surge ring, which goes around the winding here. And basically what that will do is it prevents high current from causing these windings to flex and bow out positions that can cause it to eventually fail. So the first thing we're going to do, with some more strings, we're going to attach the coils here. Alright, so this is our polyester resin fiberglass bonding tape we're going to be putting around this motor. Start here. Winding place. First time around won't be super tight because okay, and for the next part of this process, we're going to tie down the back end here. Now that we have our phase cloth cut and our surge ring installed, basically take this string here. This is a special nylon heat shrinkable string. Cut off so much of it here. Go around it, but the plan is to just get enough to be able to handle it and then tie onto it later. Slide under here. We are done with this end. Everything's tied down, and now we're just going to flip it over and we'll do the lead end. Okay, now we have the lead end up here. Next part of this process will be just like on the other end. I'm going to crimp these coils down, move the leads out of the way, and then we'll push the phase cloths down, trim them all up, and then install the surge ring. After that, we'll do the connections. So for the next part of this process, we're going to do our connections. Let's say 2Y connection, use 2 circuits, Y type. Basically what we're going to do, this is mostly going to be jumpers. What we're going to do is we're going to eventually these will just get twisted together, but get them together and then trim them, burn all the insulation off first. Yeah. So, because there's so many connections on this one here, we're going to do this in stages. We're just going to start by doing the pole connections, also called the jumpers. First thing we're going to do, we're going to clean off all the insulation on the leads so that we can get a good connection when we go to weld them. Alright, so now you see we've got all these cleaned up. Now all we're going to do is just going to go through one of these, push them up. Real good. Prepare for welding. Alright, so next we're going to be turning all these up, ready for welding. So now we're going to weld all of our jumpers. So we'll start out by melting it up a little. So for the next part, we're going to sleeve all these connections down here. Okay, once all of these are sleeved, it's going to go through, start folding these up against the winding. Alright, so this is the point where we finish our connections. This is where we hook up our 2 Ys and the 3 leads. Alright, so next we're going to attach the leads. We already did the Ys right here. There's not much difference between that and the connection there. There's one more lead on there. But now we're going to attach our leads. Basically, as we do, that's the end of the wire. Out there. For all 3 of our leads. we've got those attached, we'll trim them and weld them just like the others. Okay, so see here, we've welded our wide, welded our leads on. Now we're just going to tape them up, sleeve them, and then we're going to tie it down just like on the other end. Alright, and here we have the finished motor. Everything's tied down. We are ready to go over and run a number of tests on it, like the high pot and the surge, and a spin test. Okay, I've got this over here. We're going to do the high pot and the surge test on this. We've got the thing hooked up. Screen here. Now we're going to, what we're going to do is start with a high pot test. What that's going to do is going to make sure that the insulation, all the insulation is good. None of the wires are touching anything metal. Basically, it's an insulation integrity test. We're going to do a 1-minute test. Let that run. Okay, so for the next part, what we're going to do is we're going to run a spindicator test. And so what that does is make sure that the spindicator right here, which is basically just a little rotor, spins the same direction all the way around, doesn't stop or reverse direction in any location. Basically, it makes sure that we don't have any reverse pulls of any kind. Most of that would usually show up on the surge test, but occasionally there's the chance that you can actually get a skid surge test and find that you have a reverse pull. So, first thing we're going to do, we're going to put power to this, and we're basically going to bring the amps up to about what the nameplate normally is, which is going to be generally about a quarter to a third of the voltage. We're about 200 volts right now. Put this right here. And basically going to go around, make sure the spindicator spins evenly, same direction, all the way around the motor. There we go. Everything's good. Okay, so for the next part of the process, we're going to VPI the motor, which stands for vacuum pressure impregnation. What Nick is doing here is he is masking all the fits in the holes there, so that we can easily clean those out when that process is done. Okay, so for the next part of the process, we're going to do the VPI. You can see he has everything prepared here. He's got the leads pulled up so that we can keep those out of the varnish. So this is the tank that the motor is going to go in. This tank over here, that is the holding tank that holds all the varnish. What we're going to do is we're going to put this motor in this tank, and then we're going to suck all the air out. And that in turn will allow us to open the valve, which will allow the varnish to get sucked into the tank until the head is covered. And we will let it sit that way for about an hour or so. What that does, by vacuuming it out, it makes all the air bubbles inside of the winding expand so that they come out more easily. And the varnish can actually get into the winding more easily. Moving that into place. Lower down into the tank. And we're going to lock all those in place to seal up the tank. Now that we have the tank all sealed, we have the vacuum pump turned on. Now he's opening the valve, which will allow the pump to suck all the air out of the tank. Basically, there's 4 different functions on here. What he opened right now was the vacuum valve, that one right next to it. The bulb on the end, that's the pressure relief valve. And this one over here, this is our pressure valve, which actually pushes air into the tank. And there's that long one right there, that opens the varnish. So it allows the varnish to be sucked in or pushed out of the tank. So, right now, it's currently sucking air out of the tank. And what that will allow us to do, we open the valve right here. Will allow varnish to be pulled in to the tank. Now the sight glass, basically all we have to be able to see what's going on inside. As you can see, the varnish is getting pulled in. What we will do is we'll pull that varnish in until it covers the winding. Once that's done, we'll shut off the valve and then allow it to sit for about an hour. Okay, we have filled the tank. You look in there, might be hard to see with the camera, but basically maybe be able to see there that you see the bubbles coming up out of the motor, out of the winding. We've basically removed all the air from the tank, at least all that you can remove. You can see there 0 is basically ambient pressure, and we're close to the -1, which is complete vacuum. So now we just let this sit for about an hour or so, and until it so that it has a chance for the varnish to completely soak into the winding. Now the type of varnish we use is a polyurethane resin. That's basically a special kind of varnish that will not evaporate when you remove pressure, since you can't use a standard varnish in a VPI chamber, because lack of pressure will cause certain chemicals to evaporate. Okay, this motor's been soaking now for about an hour and a half. What we're going to do is we are going to relieve the pressure in there. Actually, I should say we're going to let the air back into the tank. So he's opening the pressure release valve. Alright, now that the pressure has been equalized, he's going to close the relief valve. Now he's going to actually push air into the tank. Now we're pressurizing this tank. Now that we've pressurized the tank, we're going to let it sit for about another half an hour. Okay, now that we've let it sit, we're going to open the varnish valve again. And now what we're doing, now that it's pressurized, we're letting the pressure push the varnish back into the holding tank. So we will do that until the tank has been emptied, and then we will open the pressure relief valve again. Okay, now that the pressure has been equalized, he's going to loosen all the lid nuts there and lift it up, and we can pull the tank, or pull the stator up and let it drip. Okay, now the nuts are loosened up. We're going to lift the lid up here. There's our motor, now fully varnished, BPI. Now we're just going to lift it up with the hoist and let it sit for about 15 minutes so that it can drip into the tank. Okay, now that it has dripped, we're going to put it in the oven here. We're going to bake it out at 300 degrees for about 4 hours. And then it'll be all done. Be ready to assemble. Putting the top thrust bearings in. Alright, now that we have the motor assembled, we're going to test run it. Got Willie over here in the test station. Got run voltage to it. Here we go.